Hello everyone, this is a short video for impulse response of a system. Impulse response of a system Hn is the output of the system when the input is delta n. Here we have two examples. The first one is the moving average system. Yn equals the average of three inputs, as you can see here: xn minus 1, xn minus 2. When we apply delta n for the input, we get the impulse response of the system Hn. As you can see, we put delta n for xn, delta n minus 1 for xn minus 1, and delta n minus 2 for xn minus 2. This is the output of the system when delta n is the input, and this is the impulse response. If we want to draw this filter, we need xn minus 1 and xn minus 2. Therefore, we have to put here delay elements z to the minus 1. The output of the first delay element is xn minus 1. The input is this xn minus 1. The output of the second delay element is xn minus 2. Here the coefficients of the filter is 1 over 3. As you can see here, the addition of three terms will be the output of the system. This is an FIR filter, finite impulse response filter. The second example is a bit complicated. As you can see here, there is an output of the system used as an input. Here we have yn, the output, but yn minus 1 is used as an input of the filter. Therefore, here this filter is a first order recursive filter, or infinite impulse response filter. To obtain the impulse response of the system, we apply delta n function as an input. Let's put here delta n for xn and delta n minus 1 for xn minus 1. Then the output yn will be hn, and yn minus 1 will be hn minus 1. But we can't obtain hn from here because this is an additional term here, hn minus 1. Therefore, we utilize Fourier transform. The Fourier transform of hn is he to the j omega. And the Fourier transform of hn minus 1 is he to the j omega times e to the minus j omega. According to the Fourier properties, the time shifts, here there's a time shift, becomes an phase multiplied by the term here. And the Fourier transform of delta n is 1, here 2, because of the coefficient, and delta n minus 1, Fourier transform is 1, but there's a time shift. Therefore, we here in frequency domain there is a phase, additional phase here, e to the minus j omega, because of this minus 1. Here there is minus 1. Okay, and we can take this part in parentheses of he to the j omega. Then we can take this part to the right side of the equation as a denominator here. Then we can divide this in two terms here, separate them in two terms. As you can see, we know this inverse Fourier transform here. As you can see, 2 over 1 minus 1 over 4 e to the minus j omega's inverse Fourier transform is here. 1 over 4 is the root, and 1 over 4 to the n un. Here let's take the inverse transform of the second term. Here, as you can see, multiplication e to the minus j omega. What does that mean? According to the Fourier transform properties, this makes a phase shift. This makes a time shift in the time domain. Okay, for this part of the term, here we have the Fourier transform, inverse Fourier transform. If we add this part here, we have a time shift here. What is the time shifted? -1, as you can see here. We shifted this term one sample. Okay, therefore we get n-1 and n-1 for all n's. Okay, the addition of two terms here, this term and this term, will be the impulse response of the system, as you can see here. If we would like to draw the filter, we take the system equation, but here we need only yn at the left side of the equation. Okay, we take yn-1 to the right of the equation, right side of the equation. Here, to obtain xn-1, we need a delay element. We put it here. Now here, this part is xn-1, and it should be multiplied by -1/2, and xn must be multiplied by 2, as you can see here. An addition of these two terms is added here, and also here yn-1. We can obtain this from the outside output of the system. Here we put here a delay element here, and yn-1. We get this from this and multiplied by 1/4 and add them to the other terms, and we get yn from here. This is a direct form 1. As you can see, as you know from signals and systems, the direct form 2 has less memories or delayed elements. We take the right side of this system to the left and left side to the right. Therefore here 1/4 comes here, -1/2 comes here, and 2 comes to the right side. That's all. We get direct form 2.